Hi friends, welcome back. Welcome to the Java Coding Insight and Interview Preparation channel. Today we are going to solve Code Festival 2017 final problem Zabutan. So before we start looking into this problem, details some examples related to the problem and solution, I want to mention that my channel is dedicated to help people in their Java and coding interviews. On my channel, you will find lots of helpful videos that can help in your interview preparation. There are over 350 different varieties of solved coding problems which are taken from previously asked coding interview questions by big tech companies like Google, Facebook, Amazon, Apple, Microsoft, Yahoo, and many other big financial companies. So if you are preparing for any Java interviews or coding interviews, this channel can be definitely helpful in your interview preparation. So please subscribe to the channel now. So let's take a look at the Zabutan problem statement first, then we'll go through some examples and then we will discuss our Java solution for this problem. So in the final code festival in some year, there are n participants. The height and power of participant I is HI and PI respectively. Ringo is hosting a game of stacking Zabutan. Zabutan means cushions, right? The participant will line up in a row in some order and they will in turn try to add Zabutan to the stack of Zabutan, right? Initially the stack is empty. When it is participant ith turn, if there are HI or less Zabutan already stacked, he will add exactly PI Zabutan to the stack, which means that if the height of the Zabutan, right, it should be less than basically HI means his height, right, then only he will be able to stack Zabutan. And how many Zabutan he will stack? The more Zabutan he will stack is equal to his power, basically PI, right? So otherwise he will give up to do and he will not do anything, right? Ringo wants to maximize number of participants who can add Zabutan to the stack. How many participants can add Zabutan to the stack in optimal order of participants? So basically you can imagine it like, Zabutan is like a cushion and there are different participants and they have to stack stack the Zabutan basically, right, on one after other, right? So they can only stack, like put onto the stack, if their height is more than the height of the like Zabutan, right? Otherwise they cannot put it on the stack, correct? So that's what the problem saying. So they have given us some examples. So let's take some examples on whiteboard where we can discuss more how we can, what the problem is and how we can solve it, right? So this is the first example. So they have given, so there are three participants, right? The first column, this first column, right? So this is height of the participant and the second column is the power of the participant, right? So for example, first participant's height is 0 and power is 2, second's height is 1, power is 3, third's height is 3, power is 4, right? So this is given to us and we have to find out how many participants can participate into the stacking of the Zabutan, right? And they can only stack we have to maximize the number of participant, right? So in the, since we have to maximize, in that case the order matters basically, right? So for example, if you look at this first example, right, so let's just consider that this is our stack of Zabutan, right? So it is empty in the beginning, correct? So first person, he comes here, his height is 0, so he can put this, right now his height is 0, right, means 0 height stack. So his height is also 0, so it is less than equal to 0, right? So he can put two Zabutans into the stack, right? So he has added, let's say, Zabutan here, and now now the stack height became 2, correct? So after that, if this guy comes, right, this guy comes and his height is 1, right? So it means that he cannot put it, he cannot reach here, right? Because his height should be more than or equal to 2 only, then only he can put it into this Zabutan stack, right? So this guy cannot participate actually, correct, in this case. So after that, this guy comes, right, 3 comma 4, his height is 3 and he can put 4 Zabutans, right? His power is 4, so he can put 4 Zabutans. So since his height is 3, which is greater than this 2, right? So he can put 4 Zabutons here basically. So he will add 4 Zabutons here, and the height of the stack will become 6, correct? So this is what the problem is basically. So in this case, as you can see, even if we try other combination, the maximum participants who can add into this stack are 2 basically, correct? So in this example that we have seen here, the first person and third person, they could add into the Zabutan stack, right? The second person could not add because his height is shorter than 2, correct? So even if we take 1 comma 3 person, let's say, so let me just now remove this coloring. So let's try like so this is, so the answer is 2 basically for this problem, right? So that's why the answer is 2, as you can see here. So even if we take 1 comma 3 first, let's say, and this is our stack, right? So 1 comma 3 came, he put the 3 stacks here, let's say, right, onto the stack. So height became 3 of the stack. Now 0 cannot put anything, right, because his height is 0, so he cannot reach here, correct? But if this guy comes 3 4, then he can reach here and he can put the 4 Zabutons, right? So 4 Zabutons he can put here. So only 2 participants actually could participate in putting the Zabutons on the stack, right? Because we have to maximize number of participants, as you can see, maximum number of participants who can add Zabuton to the stack. So this is the problem basically. I hope I already explained you clearly. So what the problem is, you understood now. So now we will see how we can solve this problem, right? So what we will do to solve this problem is we will create one participant class, right? So this is one participant, right? This is another participant, this is another participant. So we'll just abstract it out in a participant class, and it will have height and power, right? Two fields it will have. And what we will do is we will calculate the height plus power, right? So for the first one, height plus power is 2, the second one, height plus power is 4, and third one, height plus power is 7, right? 3 plus 4 is 7. And then we will use this height plus power to sort this array, right? So this is a array of participants, you can assume, and then we will sort this array. So if you look at this array now, this is already sorted basically, right? Because 2 4 7 is already sorted order basically, so we don't have to move this because this is already sorted. So once the sorting of the array is done, we will use priority queue, right? So so for example, let's say we have one variable called as used power, right? Used power is the variable we will create, let's say, right? Used power, it is 0 in the beginning, and so first participant comes, right? 0 comma 2 comes, and this is our sorry, so this is our actually, you can say, sorted array, right? And we will use priority queue here, right? So priority queue we will use, and priority queue will keep the sorting based on power basically, right? Priority queue will use power when it is sorting, right? So this is our priority queue, you can assume. So the first participant comes, so 0 comma 2, so it will the used power is less than equal to his power basically, right? So he can we can put this participant into priority queue, right? So 0 comma 2 we will put in priority queue here, right? And then we will go to the next participant after that. Now use power we will increase, right, after the first because he has put the uh, like 2 onto the stack, right? This first guy, he put 2 into the stacks, because stacks will he will put equivalent to his power, right? So it means that we will use the used power will become 2 now, right, after the first person. Now we are looking at this second person, right? So second person power is 1, which is less than this power, right? So he cannot put anything into the stack basically, right? So at the same time, what we will do is we will check with the priority queue here. So priority queue, what we will check, if this value of power is, this value is less than this current value, no, right? So in this case we don't have to do anything, right? Then we will go to the third person, Why we are doing it, I will explain you into the next example. But right now, let's just assume that. And so now we will go to the third person, 3 comma 4. So now his power is 3, used power is 2. So his power is greater than or equal to 2. So we have to put it into the queue basically, right? So we will put into the queue 3 comma 4, right? 3 comma 4 we will put it into the queue, and queue will use it based on the power, right? Based on the power. So we will have to move this 0 comma 2. So you can just assume that we will put based on the power. So 3 comma 4 we will put it in priority queue basically, right? So at the end we will just check the queue size, right? Priority queue size will be the answer, right? Because those many participants are able to put the cushions, like, or the Zabuton into the stack, right? So number, like, size of priority queue will be the answer, right? Because as you see, the second person could not put it into the stack of the Zabutan, so we did not add it into priority queue, right? So that's why the size of priority queue will give us the answer. So as you can see, that's how we got the answer 2, right? So this is one example that's given to us. So let's take a look at another example that I created to explain you another scenario. So this is where there are still 3 participants. So what first we will do is we will calculate their height plus power, right? Because that is what we will use for sorting of this array. So now as you can see, the height plus power of this one is 4, right? 0 plus 4 is 4, 1 plus 3 is also 4, and then 3 plus 8 is 11, correct? So it means that this is already in sorted order, so we don't have to reshuffle the order. This is already sorted basically, right? So first thing is we are going to sort it, right? So this one we have done. Now we will go one by one from these participants, and we will put them in priority queue, and we will use a used power variable, right? Used power. So let's just say used power is 0 in the beginning. So use power is 0 in the beginning. So the first person is coming now. This first participant is coming, and his height is 0, right? His height is 0. So let's just draw one easy stack here, and this is our priority queue, right? This is the priority queue, and this is the stack, right? So he will come here, there he can put it into the stack, right? So he will put until the 4 point, correct? So he put 4 cushions here, or 4 Zabutan. So we will also update the used power now to 4, right? And then we have to add this 0 comma 4 into the priority queue, right? So 0 comma 4 is into the priority queue now. So this is our priority queue, and this is our stack, right? Stack. So after that we will go to the second participant, right? Second participant. Now second participant height is 1, right? Which is less than this 4. So it means that he cannot put the Zabutan on this stack, right? Because his height is shorter than 4. Now what we have to do is one more check we have to do. If this is the case where he is not able to put onto the stack, then what we will do is we will compare this power of this person with the power, like with the power of this person which is on the top of priority queue, right? So this is 4, which is priority queue top, and this is 3, right? So we always wanted to keep minimum into priority queue basically, right? So if this is the case, then what we will do is we will replace this power basically with the smaller power, right? Smaller power we will replace. So what we will do is we will just change this from 0 comma 4 to 0 comma 3 here into the priority queue, right? So you can just assume that we are actually replacing this 0 comma 4 with 0 comma 3, because we always wanted to keep this minimum power. So this one, this guy, like this person, is not able to add into the stack. So in that case we are checking if this person's power is less than the priority queue's top power, right? So priority queue top power is 4. So we wanted to replace that 4 with this 3, right? And you will know in a second why we are doing it. So we replaced it with 0 comma 3. Now we are going to the third person now, right? So 3 comma 8. So we will again check this 3, right? And at the same time we have to change the at the same time we have to also update the use power to 3, right? When we updated this 0 comma 3, same time we have to update the use power to 3, correct? So use power we are always going to check. So now this third person height is 3, so we will check this 3 against the use power, right? So it is greater than or equal to this 3, right? So it means that he will be able to put onto the stack. Also, one thing I forgot to mention, that when we are changing the use power to 3, we have to also this one will change it to 3 basically, correct? The stack will change it to 3 from 4, correct? From this 3 we changed it to 0 comma 3. At the same time we changed use power to 3, stack also will change it to 3 height. So this person's is 3 comma 8, so he will be able to go to this point 3 and he will put his 8 stacks, 8 cushions here basically, right? So this guy will put it, so we have to add this 3 comma 8 into our priority queue, right? We will add 3 comma 8 into priority queue, and this is the reason why we have to update this 3 basically, right? Because whenever we want to check, like the priority queue, we want to maximize the number of participant, right? So which means that if we should keep this in the priority queue, we should keep the power minimum basically, right? Power should be minimum that can be used basically, right? So this is why we have to check it, right? So you got the idea, I believe. So this is like first this person came, he put it into the stack, so the height of the stack became 4. Now this second person 3 comma 4, when he came, he could not put it onto stack, right? Because his height is only 1. But at that time we are going to do a check into the priority queue, the height, like the 4, which is the power of the priority queue top person. If it is this person's is smaller, right? This 3 is smaller than 4, then we will replace it here in priority queue basically, right? And the reason for that is because we want to maximize number of participants, and it is only possible when we will keep this minimum, right? In that case, right? For example, if we don't do that, then this third person could not be able to put it onto stack, right? So it means that we have to change it to 3 basically. So the stack height will change it to 3 and use power also will change it to 3 here, right? So that the next participant who has a height 3 will be able to put his cushions onto stack, correct? So because we want to maximize the participants, so this is why we are going to do that. There is another example here, so I'll just show you that quickly and then we will go to the Java code. So here let's just first calculate the height plus power. So height is 2 plus 4 is 6, right? This is 6, 3 plus 1 is 4, and then 4 plus 1 is 5, right? So this one I put it as a sorted array. So 3 1 is coming first, then 4 1 is coming with 5, and then 2 4 is coming, right? This is the sorted array we have. After that this first person will come, right? So first person will come, he will put his power is 1, right? So I'll just explain you quickly here. So this is the stack, right? So he will put 1 into stack, right? He will put 1 into stack because the person can put number of cushions equal to his power basically, right? Then this next person comes, his height is 4, which is greater than 1, so he will also be able to put 1 into stack basically, right? Because his height is more, correct? So now this one will be 2, right? This third person comes, his height is also greater than equal to 2, right? This height, so he can also put 4 here basically, right? So it means that all the participants are able to participate into stacking the cushions, right? So in that case answer will be 3. This is the example that we are taking it from here. This is the second example, so here answer is 3. So I think with these examples it will be clear to you how we are going to implement this problem of Zabuton. So let's go ahead and take a look at the Java solution. So first we created a class called as participant. It is having just height and power field, right? Because we want to sort the participants array. So n is equal to 3 is given to us, and this is the height and power is also given to us, right? So we are going to create array of participants. We will read the input and we will create the participant objects here, and we will create the participant array, right? So our participant array is getting populated here, correct? So after that we are defining a priority queue here of participant, right? And priority queue is going to keep the like order by using power, right? So like in a descending way, so in the descending order, so a power minus b power, but we are negating it here, right? So so we defined the priority queue here. Then we created one variable called as use power, right? Because use power we are going to use to check if the participant will be able to uh, stack the cushions basically, correct? So after that we are going to sort the array based on height plus power. As you can see, we are adding height plus power, right? Height plus power we are using for sorting the array of participants here. And after that we will go through the participants array in this for loop, correct? Now what we will check is this use power. It should be less than or equal to the participant height, right? So that he can reach there basically to put the cushions, right, into the stack. So that's what we are checking here. If that is the case, we will increment the used power by the participant power, and we will add the participant into priority queue here, correct? Now in else part, this is the scenario that we just like discussed in detail, right? That when we have to update basically the value of the power, right? Updating the value if we have seeing less value here, right? So this is what we are doing into the else part. So if we are checking the top element on the priority queue here, if the top element power in the priority queue is more than the current, more like greater than or equal to the current participant power, right? Then in that case what we will do is we will update our used power count. We will decrement it basically, right? By the uh, we will poll this element from priority queue, and with his power we will just decrement the used power basically, correct? So as you can see here, 4 is the power, right? So we will uh, uh, so used power is 4, correct? Used power in the beginning is 4, correct? So we will poll this element 4. So 4 minus 4 we are doing, which will become 0, and then we will add this 3 into that 0 basically, right? Plus 3 we will do, correct? So it will give us 3 here, right? 3. So that's what you will see here. So first we are polling it and subtracting the power from priority queue top element, and then we are adding the current participant power into the used power, right? So this is what I just explained you here, this one, correct? And why we are doing it? Because we want to maximize the number of participants, and that will only be possible if we have to update the power here, correct, in this scenario. So after that, once we update the used power, we will just add the current participant into priority queue here, right? So we will keep looping through all the participants, and at the end whatever the priority queue size will be the answer, right? Because those are the participants who are participating in stacking the cushions, right? Means they actually are able to stack onto the stack basically, right? Because that's how our logic works. When they are stacking, we are adding it, right? When they are stacking, we are adding it. And in this case we are removing one from the priority queue and we are adding another basically, right? So number of size will remain same in this case, right? In this case, because we removed one and we added one, so size will remain same. And the reason why we did that I already explained you here, right? So thanks for watching this video. I hope this is clear to you. uh, we will go through some examples, so let's just go ahead and execute this Java snippet.
ఫ్రీడమ్ మాటలు అంటే
so we are getting here as the answer 2, which is the correct answer for this first example that we have seen, right? So we will just update this example with another example and we'll just make sure that this also works. So this is the one that this one, right? 041338. So 041338 is the example, right, where we are able to this example that we just discussed. So it should have two answer, right? So let's just go ahead and execute this code snippet. So 2 is the correct answer that we are getting, right? So let's take another example, this one where we are getting 3 as the answer, 243141. 243141, right? So 2431 and 41. So as you can see, we are getting 3, which is the correct answer, right? So we have tested this scenario also. So we tested all the examples. So this is the way we can solve AtCoder problem Zabutan. This is one important problem and interesting also. I just thought that it's good to create a video so others can also understand about this problem. If you are new to my channel, there is a AtCoder playlist where you will find a lot of solved AtCoder problems explained with whiteboarding session examples and Java code. Apart from that, there are other important playlists called as Leetcode and Leetcode solutions, code forces and code chef. It has over 350 different varieties of solved coding problems explained with Java code, examples and whiteboarding sessions for your easier understanding. So if you are practicing for coding interviews, you can practice using those playlists. Those will be definitely helpful because those constitute vast varieties of problems that are very important from coding interview perspective. So you can practice those playlists. If you like this video, if you find this video helpful and you liked it the way it's created with whiteboarding session examples and Java code, please give it a like. Also put in comments how this video helped you in understanding this problem in easier way. Also subscribe to the channel. Your subscription to the channel is really important for the channel because that is the way the videos can reach to more people who need help in solving coding problems. Those people who need help can also look into these videos and understand how to approach different varieties of coding problems using Java and how to use Java data structures, libraries, APIs to solve different varieties of coding problems. If you like this video, please share it with your friends and colleagues. Also give it a like and thanks for watching this video.